Alright guys, now in today's video we're going to be looking a little bit at integration. Now we're going to kind of be taking some small steps here at the beginning. We've already started putting together the ideas of integration. You've been able to do a definite integral over a little bit of a range and we've started trying to kind of reason through what the integral of a specific function is. We're going to do that a little bit more with this, and so we're going to look at how we can again use the derivative to help us understand and be able to put together the rules or the laws eventually for differentiation. Now you'll remember in class we talked about the properties of differentiation, which I put up here on the right hand corner, which are going to be helpful. So let's go ahead, or for integration up here in the top right hand corner. So let's just start with the first example here. I'm going to go through two of them right now. So the first example is we have an equation y equals x cubed plus x squared. We're going to find the derivative of that and then see if we can use that idea to help us to find the integral of 3x squared plus 2x dx. Okay, so first let's go ahead. We're going to say, okay, dy dx, or y prime, is equal to, when we take the derivative, we can take the derivative of the pieces individually when it's a polynomial. And so we can, when it's separated by a plus or minus, so we'll take the 3, move it to the front, which will make 3x, and then subtract 1 from the exponent, which is squared, and then again plus 2x. And so by looking at that, we can then see that the derivative of this function right here is 3x squared plus 2x. Now if we're looking for the integral of 3x squared plus 2x, we know that the integral is the opposite. So if the derivative took us this way, the integral should take us back to what we started with. And so we can now say, okay, well, in that case, the integral of 3x squared plus 2x dx is going to be the opposite, which is going to be x cubed plus x squared. Now we also recognize that it could be plus some number, some constant. There could be some number there that we can't see, that when we take the derivative it goes away. Because remember, a derivative of a constant is 0. So we do want to make sure that when we do this indefinite integral that we include the plus c. And so there we go, that's the first one. Now, sometimes things are going to look a little bit different. And so let's go ahead and look at this next situation. So we've got the derivative of the natural log of 5 minus 3x plus x squared. Now the derivative of the natural log of 5 minus 3x plus x squared is, remember, with natural log we could write this as the natural log of u, where u is equal to 5 minus 3x plus x squared. Now the derivative of the natural log of u would be 1 over u. Now if we do that, we also have to multiply by the derivative of this inside function, which just happens to be, put the 2 in front, 2x, and then minus 3. And so this right here is the derivative of my u. And so if I rewrite that, then it should give me 2x minus, that is not a 2x, 2x minus 3 over u, which was 5 minus 3x plus x squared. So that was finding the derivative. So this is the derivative of the original function. So now what it wants us to do is consider that and look at this integral. Okay? Now this integral is 4x minus 6 over 5 minus 3x plus x squared. Now if we look at these two, we notice that this one right here is almost the same, except for one small thing, right? The numerator. But how is the numerator different? Well, hopefully you recognize that the numerator here is just double of that one. So let's rewrite it. We're going to rewrite this so it's the integral of 2 times 3, I did it again, 2x minus 3 over 5 minus 3x plus x squared dx. Now we notice that this rule right here, the integral from a to b of c dx, sorry, just kidding, not that one. We want the integral with being multiplied by a constant, this one right here, sorry. So there we go. There's our integral. If we have a constant which is being multiplied by a function, so that's this 2, that's being multiplied by my function, I can actually pull that 2 out and put it outside of the integral. So now if I have 2 times the integral of 2x minus 3 over 5 minus 3x plus x squared dx, then now we can see that this inside, when I take the integral of that, it should give me the natural log of 5 minus 3x plus x squared, because the derivative of that gave me the 2x minus 3. And so I can then rewrite it as 2 times the natural log of 5 minus 3x plus x squared. Now it is an indefinite integral, so please don't forget when you get to the end that we've got to add on that c, that arbitrary constant that we're not quite sure what it is. All right, so this, like I say, this is just, you wouldn't really have to do something like this on an exam, but this is understanding integrals and understanding eventually where these rules are going to come from. Now, some of you already kind of has started to create your own rules in your mind. The next video that I'm going to show you is actually going to present to you the rules of integration for different types of functions. All right, so go on to the next one.